Scenario. The International Space Station with a mass ms is orbiting Earth about 400 kilometers above the Earth's surface. Given that the Earth has a mass of me and a radius re, the question asks us, what is the approximate acceleration of the space station due to the gravitational force exerted by the Earth? Here I gave you the equation for the force of gravity that the International Space Station will feel due to the Earth. This can be derived in another video called the gravitational force equation with an additional distance. This question asks us to solve for the acceleration. So the answer, what you're going to do is set the force of gravity that the space station feels with the force of gravity between the two objects. So Fg of space station will be the force of gravity that the space station feels. That's going to be equal to the force of gravity between the two large planetary objects, the space station and the Earth. It's going to make more sense when you make the substitution. So the force of gravity on the space station is just mass times acceleration, or here would be mass times the gravity. And the right hand side is that big m times m over r squared equation that gives us the planetary gravitational force. Okay, from here you can now divide the ms to both sides, so canceling it. So this little g, which is the gravitational field, is defined by this. You can now plug in the value. This is the mass of the Earth, the radius of the Earth, and the gravitational constants here. So notice the gravitational constant here is in meters. That's why the 400 kilometers was converted to meters here. If you plug in the values here, you should get roughly 8.655 meters per second squared. This is actual real values. This is the real value of the Earth. That's the real mass, that's the real radius, and that is the real distance that the International Space Station is above Earth. So the International Space Stations will feel the G at 8.655. This makes sense because on Earth, if we stand on the surface of Earth, we feel 9.8. As we move away from the surface, it gets less because there is an inverse relationship. So this value here is under the standard 9.8 squared because it is further away from the Earth's surface. So there you go. This should tell you about the acceleration. You're like, wait, I thought this is A. Well, this G here can be seen as the centripetal acceleration is equal to the gravitational field. Okay? There you go.